cuma pura. Aduh Eke dapat lupa, sampai Eke sudah pabende. Eke sadar, lekong sos pandai. Pas Eke besadar, lekong sos skidi, 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 skidi. Eke so mebong, Eke so mebong, Eke so mebong, Eke so mebong. Eke besadar, lekong sos skidi, 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 skidi. Hari malam Eke mabura, aduh Eke dapat lupa, sampai Eke sudah pabende. Eke sadar, lekong sos pandai. Aduh banyak lekong, mari Eke takut sontong, cuma boleh mau keken. Lekong, lekong, betong, lekong, betong, 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 lekong, lekong, betong, lekong, betong, 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 lekong, betong, betong. Mau keken, Eke so jadi melong, karena pe banyak lekong, jalur-jalur baku jalur, Eke so mulai mebong. Hari malam Eke mabura, aduh Eke dapat lupa, sampai Eke sudah pabende. Eke sadar, lekong sos pandai. Pas Eke besadar, lekong sos skidi, 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 skidi. Eke so mebong, Eke so mebong, Eke so mebong, Eke so mebong. lekong so skidi, 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 skidi. Hari malam cuma pura, aduh eke dapat lupa, sampai eke sudah pabende, eke sadar lekong so pandai. Aduh banyak lekong, mari eke takut sontong, cuma boleh mau keken lekong lekong betong lekong betong 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 lekong lekong betong lekong betong 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 lekong betong mau keken eke so jadi melong karena pe banyak lekong jalur-jalur baku jalur eke so mulai megang. Hari malam cuma pura, aduh eke dapat lupa, sampai eke sudah pabende, eke sadar lekong so pandai. Pas eke sadar lekong so skidi, 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 skidi. Eke so mebong, eke so mebong, eke so mebong, eke so mebong. Eke sadar lekong so skidi, 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 skidi. Hari malam cuma pura, aduh eke dapat lupa, sampai eke sudah pabende, eke sadar lekong so pandai. Aduh banyak lekong, mari eke takut sontong, cuma boleh mau keken lekong lekong betong lekong betong 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 lekong betong 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 lekong betong 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 lekong betong.
integrity, and respect. This is STAR Training Center, sustaining teacher leadership and academic vitality through research. Let us remember that we are in the loving presence of our Lord. Lord, we offer you our webinar today. Make this a safe and healthy place for learning. Help us to be engaged and challenged as we go on through our topic today. Support us so that all our learning activities be accomplished for your greater glory. Above all, help us to have a good heart so we can be an instrument to do good things. We ask all these in your glorious name. Amen. Before we begin this webinar, here are some important house rules that we shall observe during the entire duration of our webinar. First, stay focused and don't multitask. Also, please close all apps that could influence connection speed. Second, take notes. Take down the key ideas you will hear. Third, ask questions concisely. You may type your questions in the chat box. Our learning facilitator will try to address all your questions during the question and answer portion. Lastly, respect the learning facilitator and other participants. Be respectful. Keep your contributions helpful and considerate of the learning facilitator and other participants. Thank you.
Sunday to all of us. Magandang umaga po sa ating lahat. We are now on our last live session, and for today, we will learn about the test of reliability from none other than our resource speaker, Dr. Carlo P. Magno. Good morning po, Doctor. Morning, Doctor. We
Hello.
cannot hear you po. Yan po. Okay na po,
Okay.
Doc.
So, good morning, everybody. Um, this is your last session with me for today. So, in our first session, we have focused on the concept of validity, and then we went through how to analyze the dimensionality of your assessment information through exploratory and confirmatory factor analysis. That was yesterday. And these concepts on CFA, especially, are going to be used for today on how we introduce some aspects of test reliability. Okay, let me share my screen now so that we can start. Okay, you can see my slide now.
Yes po, Doctor.
All right, so for this morning, we focus on the reliability of a test. And these are the things that we are going to talk about this morning. First is what influences test reliability, and then the different forms of test reliability. Okay, let's have our first volunteer. Okay, let's have a rundown on our volunteer. Who is the first one?
Good morning, Doctor. Mr. Alfredo of Presyo.
Alfredo Ofresio. Okay, kindly turn your microphone and say hi, Sir Alfredo. Hello, Sir Alfredo. Okay, let's move on to the next one.
Sir Carlo J. Alpite.
Okay, Sir Carlo. Can you turn on your microphone and say hi? Hello, Sir Carlo. Okay, the next one, sir.
Ma'am Elaine Bermiso.
Elaine Bermiso. Okay, Ma'am Elaine, can you please turn your microphone on and say hi? Ma'am Elaine? Hello, Ma'am Elaine. They seem not to be responding. Okay, let's look at the next one.
May we hear from Maria Arlene Villegas. Ma'am
Okay.
Maria Arlene Villegas.
Okay, Maria Arlene Villegas. Okay, Ma'am Maria Eileen Villegas. Can you turn on your mic? Okay, she's not here yet. Okay, the next one.
Virginia Manalang.
Okay, Virginia Manalang. Okay, Ma'am Virginia, can you please turn on your mic?
Dear participants, you're
Okay,
allowed to
Ma'am
turn your
Virginia.
microphone.
Ma'am Virginia. Okay, the
No one
next
is
one, sir.
responding. Mr. Vic Tivar.
Vic. Okay, Sir Vic. Wala rin. Okay, next. Number 7.
Ma'am Rosario Tandok.
Okay, Rosario Tandok. Miss Rosario, can you please say hi? Okay, next.
Okay, Ma'am Queenie Baroro Salang. Ma'am Queenie.
Okay, Ma'am Queenie. Hello, Ma'am Queenie. Okay, probably let's just change and let's just choose from the ones that are here. Sarah Jane, I can see you. Okay, Miss Sarah Jane, can you please unmute and say hi? Miss Sarah Jane. Hello, Miss Sarah Jane. Okay. Let's try Vladimir Reyes. Sir Vladimir. Ayan. So the first one who volunteered is Miss Odette. Miss Odette, can you say hi again?
Good morning, Doc.
Okay, yan. Miss Odette Justo volunteered. Next, let's try Sir Vladimir Reyes. Can you say hi? Ayan. Good morning. Sir Vladimir, you will be the next one. Sir Vladimir. Number 3, Jerome Ramos. Jerome?
Yes, sir.
Okay, so you'll be the third one, Jerome Ramos. Okay, so when I call you Jerome, you will be answering. Okay, let's try the others. So Ma'am Rosario is here. Ma'am Rosario, I can see you. Can you please unmute? Ma'am Rosario, Tandok. Oh, sorry, multitasking po ako. I'm also at the face-to-face seminar at the moment. Too bad. Okay. Let's ask Sir Rex Salvador. Sir Rex. Ayan. Si Janelle May. Hello, Janelle May. Janelle May.
Good morning po.
Okay, Janelle, I will be calling you to answer some questions later. Ha, Janelle May. Okay, one more. Irish. Ayan, Marge. Hi, Marge. Marge, can you say hi? Marge Mabansag. Marge.
Hi po.
Hello, so Marge, I'll be calling you later. Okay, so make sure to turn on your mic. That's Marge.
Okay.
And then Jennifer Mangali. Jennifer Mangali.
Yes, sir. Good morning.
Okay, good morning, Jennifer. So I will be calling you later, Jennifer. Okay, and the last one. Okay, who wants? Sherwin. I can see you, Sherwin.
Good morning po.
Okay, so Sherwin, I will be calling you later. All right, so we have 7. Okay, let's continue now, and we'll start with Miss Odette.
Morning, Doc.
Okay, so I will, so these are the things that we're going to talk about today, Miss Odette, what influences test reliability and forms of test reliability. And then we begin actually with a case. Okay, and then we'll try to work out these particular cases later on to illustrate what reliability is. Okay, so I'm going to show you this particular set of case. There are three, and then let's try and you try to identify whether the measure is reliable or not. Now, take note for the rest of the audience that the cases that I'm presenting are very rough illustrations on reliability. And as we go along further, we'll look at more accurate ways of estimating reliability. Okay, so I'll be reading the case, Miss Odette, and then tell me afterwards if what is being referred to is reliable or not. Okay, number one, a rubric was used to rate the speech of 10 students. One judge gave an average rating of 2.1 out of 4.0, and another judge gave a rating of 4.0 out of 4.0 for the performances. Okay, Miss Odette, you
Yes,
think
Doc.
this particular case is reliable?
Maybe the test is reliable, but the judges are not.
Okay, so which tool are we looking at here? What tool are we looking at here?
The rubric, sir. The rubric
It's
to
actually
rate
the rubric.
for
Okay,
speech.
so the rubric as our rating tool is actually equivalent to a measure or the like a test, but this is not a test. Actually, in any measure that you have, you can actually employ different forms of reliability. But in this particular case, it's a rubric. And we have two judges. And Miss Odette noted
Yes,
an
Doc.
important aspect here. Miss Odette said that the judges' rating may not be reliable, but the tool can be reliable. Or Miss Odette, can we say that the rubric can be valid, but the ratings may not be reliable? Can we say that?
Yes, that will also be correct, Doc.
Mm-hmm.
Also, maybe because the rating is limited to 4 in terms of the score. Then the
Mm-hmm.
more scores, now say for example, score 1, 2, 3, 4 might not be enough to capture the entire performance.
Okay. However, Miss Odette, take note, it's very difficult to make descriptors of a rubric.
Yes, Doc.
Okay.
I know.
That's why sometimes we are limited to a scale of 1, 2, 3, 4, or sometimes just 1, 2, 3. Okay.
Okay.
Miss Odette, what made you say that the judges are not reliable?
Because one judge actually scored very low,
Mm-hmm.
2.1 out of 4, and the other one actually scored the perfect. Okay, gave
Okay.
a perfect score of 4.0 out of 4.0.
Okay. So meaning to say, the two judges gave a very discrepant
Yes,
scoring that made their ratings not reliable.
unreliable. Yes, Doc.
All right. Okay, so this is an important aspect that we need to consider when estimating reliability of rating scales, especially when you're using judges.
Yes,
And this also illustrates a requirement or one way of conducting reliability. If you have a performance and you want to see consistency or similarity across raters, this is a technique. You get 2 or more judges. And we say that the judgment is reliable if our judges provide almost the same ratings. In this particular case, it is not, because 2.1 and 4.0 are too discrepant. Okay, thank you, Miss Odette.
thank you, Doc.
Thank you. The next one. So the next one, Vladimir. Vladimir, your turn.
Yes po.
Okay, Vladimir, the second case. A teacher made 2 versions of a test on simplifying mixed fractions with 5 items each. The average score of the students in one version is 1.23, and the other version, it's 4.12. What is our measure here? What is the tool that we are using?
The test, sir.
What test?
Uh, The test on simplifying mixed fraction
All
with
right, all
5
right,
items.
all right. How many tests do we have?
2.
Okay.
2
Now,
versions.
yes, there are 2. Correct. Sir Vladimir, why did I show or why did I demonstrate here 2 tests? What is the intention of providing 2 tests?
To test if their answer is reliable.
Okay. Making
Same.
use of 2 tests, how will we know from the 2 tests that the answers are going to be reliable?
Sa pagkakatanda ko po sir, kapag ka po ganun ay parang ginagamitan ng test of reliability. Parang mga ganun.
Okay. Bakit dalawang test kailangan?
Kung makita nga pareho yung answer.
You have a coach, Vladimir. Okay. Yes.
Ayun,
Why do you need to have 2 tests, Vladimir?
yun po, nabanggit na nga po na dapat po kung same questions yun or same competencies, dapat parehas yung masasagutan.
Yes.
Or, yun po.
Okay.
Depende.
However,
Yun po.
yes, correct. So, however, in the first version, the average of the students is 1.23, and in the second version, the average is 4.12. So, can you say it is reliable?
Siguro po depende kung sa time ng pagbibigay ng test.
But can you say, given the scores of 1.23 and 4.12?
So kung ganun po, maaring hindi po ganun ka-reliable yung naging score po na.
Why?
Yun po.
Why? Why?
Same with yung the previous one po. Sobrang layo po nung discrepancy nung mga scores.
Yes. Okay. So the 2 average coming from the 2 versions of the test on simplifying mixed fractions are 2 discrepant. It's 1.23 and 4.12. So we can say that reliability may not have been attained here. Okay. Thank you, Vladimir.
Thank you po.
Okay. Next, Jerome. Ready? Jerome? All right. Your turn, Jerome. So a coach made 20 athletes run and got an average speed of 2.5 minutes for 100 meters. In another occasion, the same athletes ran and got an average speed of 2.48 minutes for 100 meters. Okay? Sir Jerome, what are we assessing here?
The average speed
The
of the
average
athlete
speed
of the
of
20.
the athlete. Yes. How many times did we obtain the average speed in running?
2 times, sir.
2 times. Why do we have to get the average speed 2 times? Why 2 times?
As far as I know po kasi, if it's like the test lang din po. Kumbaga, kung sa umpisa napasa mo niyo po yung test, the other one should be also passed then. Same test din ang mangyayari. At parehas dapat ay pasado sila to measure reliability po.
Okay, now, in this particular case, what was the speed during the first run?
2.5 minutes po.
Okay, how about the speed in the second run?
2.48.
Okay, so question. Is the measure reliable?
Yes, sir.
Why did you say?
If we're going to look on their scores or their average, magkalapit po kasi sila, sir.
Yeah, so we can say at least that somehow there is reliability here on the number of minutes being run because, okay, 2.5 and 2.48 minutes are almost equal, almost. All right, thank you, Jerome. So this illustrates quite a reliable measure for speed. All right, so let's start now. So thank you, Jerome. So so the rest get ready a little bit later. Ma'am Janelle, Miss Marge, Miss Jennifer, and Sherwin a little bit later. All right. So what is reliability? I think reliability is illustrated on the first 3 cases that we have shown. So what we are really after in reliability is the consistency of the responses on the measures. Okay? So these consistencies needs to be seen when retested on the same person. Like the case of the simplifying fractions, you have two versions of the test and it is retested to the same person. The same is also illustrated among the athletes who run for the first time and who run on the second time. So they were retested. Okay, there was retesting on the same person. Second condition, when retested on the same measure. Okay, we have the second case where you have a single rubric, and the single rubric was used across different students. The third, similarity of responses across the items that measures the same characteristic. Okay, and we'll illustrate this one a little bit further. Okay, so this is reliability. What we're after is the consistency of responses when retested to the same person or making use of the same measure and the similarity of responses across items that measure the same characteristics. Now, there are actually different factors that influence the reliability. And the reliability estimate can be high or low depending on the following factors. The first one is the number of items in the test. Generally, our rule here is that the more items that you have in your measure or in your test, the more likely that the reliability estimate is going to be high. Okay, so that's why when you develop a measure, it is advised that you have a large pool of items because when you compute for the reliability, okay, it will be accurate. And then along the way, after you do your further item analysis, when you do your EFA or CFA, there might be some items that you need to take out. And when you take out these items for your final form, reliability can be reduced. The second point. So there are individual differences of the participants. Okay? So these individual difference would actually refer to some innate characteristics of your participants like fatigue, their concentration, okay? Innate abilities like scholastic ability, intelligence, aptitude, their perseverance and motivation to take the tests. These differences are brought along when they start taking your test, and this is a source of variation. Usually, you estimate these individual difference making use of your standard error of estimate. So these individual difference factors changes over time and it affects the consistency of answers in the test. So it might be at one point in time, the person experiences fatigue because of a previous activity, but in the second occasion, the person is not experiencing fatigue. So these are some individual differences that you can consider. And then the next factor is the environment, the external environment. When the testing condition explains much of the variation that can occur in the scores, like the room temperature, the noise level, the depth of the instruction received by each of the participants, the exposure to the materials, and the quality of the instruction provided during the testing time affect changes in the responses of the examinees on the test. So these are the three factors that influences reliability. So the idea here is that the more we are able to control these factors, the better would be the consistency of the responses that we should be able to get. Now, there are different ways on how you establish test reliability, okay? And the specific kind of reliability estimate will depend on, number one, the kind of variable that you are measuring. If you have a performance, you have a different way of estimating reliability for that. If you have a test that measures ability, you have a different set of reliability that you can use for that one. If you have aptitude and the more stable skills, like finger hand dexterity, typing, you have a different way of establishing reliability for that. The type of tests, okay, will also depend on the kind of test of reliability that you will be using and the number of versions that you have in your test. So it will depend on these three conditions. Okay, let's talk about the first one. I'm pretty sure that you have heard already of the test-retest form of reliability. So in the test-retest, you administer your test at one occasion to your examinees. And then in another occasion, you administer the same test to the same set of examinees that you have. This is test-retest. And usually in a test-retest, the constraint that you are putting here is the time interval. So the time interval between the first occasion of the testing and the second occasion of the testing can range up about to 6 months. Okay? And sometimes your minimum can be about 30 minutes in between these two occasions. Okay? So when you get observations, let's say you have a set of 30 examinees during the first occasion, and you have another or the same set of 30 examinees during the second occasion, more or less, the scores that you should be getting from the same respondents should yield consistent responses. This is test-retest reliability. So reliability here is tested across time. You are testing whether the scores and the responses will remain stable across time. That's why test-retest reliability is a test of temporal stability. Okay, take note. The test-retest is only applicable for variables that are stable. What are these variables that are stable? Example would be your aptitude, your psychomotor, temperament. Okay, examples of psychomotor measures would be like your typing tests or tasks in physical education, like the running that was illustrated a while ago. Now, a while ago, we were illustrating consistency of scores by reporting mean scores of the first occasion and the mean scores of the second occasion, because I wanted to illustrate roughly how consistency can easily appear to you. However, that is not an accurate way of determining reliability. In order for us to accurately determine reliability, especially if you have more than 2 or more set of observations or more than 2 respondents, okay, it is advisable to compute for the correlation of the scores on the first occasion and on the second occasion. Remember last time when we talked about validity, we have also talked about how to correlate scores. Okay, so usually if you have 2 interval observations, like in this particular case, let's say that your first test, that the test that you that was administered to the participant is an aptitude test. Okay, so you administer that aptitude test in the first occasion, and then after 30 minutes, let's say after 2 weeks, you administer again the same aptitude test, the same set of examinees that you have. What you can do to determine if you get consistent results here is to correlate the first set of scores with the second set of scores. Since aptitude is an interval data, you can now make use of the Pearson R in order to do the correlation. Okay, let me illustrate that further. If you really have consistent scores from the 2 occasions, from the first occasion of the aptitude and the second occasion of administering the same aptitude test, you need to be able to form a linear line between the scores of the first occasion and the second occasion. So you can actually plot the scores in a scatter plot like this. What I'm saying, and I'm referring to a linear line, would be a straight line going up. If you will notice, you see a pattern of increasing scores of score 1 and score 2. As score 1 increases, score 2 also increases. Okay. Now, how do you now interpret the coefficient that you get? By the way, you get a correlation coefficient as an estimate of the test-retest reliability. And I'm starting with the concept of a linear regression because this is also going to be applicable for the succeeding estimates of reliability. All right. So when you get an estimate of a correlation coefficient, it ranges from a value from 0 to +1 or 0 to -1. So the closer is the correlation coefficient to 1.0, the stronger is the relationship between the two scores. And the stronger is the relationship, the more they produce a straight line when you do a scatter plot. Now, if you look at the cutoff here, if you get a correlation coefficient of 0.80 to 1.0, this is very high or very strong relationship. From 0.6 to 0.79, high relationship. From 0.40 to 0.59, substantial. From 0.2 to 0.39, low. And from 0 to 0.19, you get a negligible. Now, in a particular case where we want to attain test-retest reliability, the magnitude of the correlation should be positive. Because if the scores from the first occasion is increasing, the scores on the second occasion in taking the aptitude test should also be increasing. So you expect a positive magnitude. And what does a positive magnitude looks like? It should be like this. And when you estimate your correlation coefficient, the value of your correlation coefficient should also be positive and not negative. Now, more importantly, okay, your correlation coefficient needs to be significant. Okay, so when you say that your correlation coefficient is significant, it's actually compared to an expected probability of correlation coefficients. And usually, when you were in college, this expected probability of correlation coefficient is what you call as a critical value. And you take it from the table, okay, at the appendix of your statistics book. And usually, you compare that expected value or that critical value to your correlation coefficient that you have computed for. Okay, and remember last time we were talking about plotting it in a normal distribution, and you need to exceed an alpha level of at least about 0.05. Okay, if your correlation coefficient estimates beyond 95% of the confidence level, it means to say that your correlation coefficient is significant and it is free, and it is you get a high probability that the correlation is not due to chance. That's what we mean when we say that the correlation is significant. Okay, let me illustrate to you now, okay, how to compute a correlation coefficient, okay, making use of JASP. So yesterday, I have sent you the link of JASP, and JASP is actually a freeware where you can download it for free and you can do all of the analysis that we can have talked about yesterday, including the EFA and CFA. So you can see my screen now that I'm opening my JASP.
Yes po, Doctor.
Okay. So my JASP is being opened. Okay. So here's your JASP. Okay. By the way, I have previously typed my data in Microsoft Excel. But JASP will not be able to read your Microsoft Excel. So from Microsoft Excel, your data needs to be saved as .csv. It needs to be saved as a .csv file. Okay, so I will now open my data. Just click this one, open data file, and take the JASP for a spin. And then and then you can click open. I have already placed it in my recent file and it's here. So I'll just click this one. So it's now importing my data. So this is now my data inside JASP. And I'm making use of the same data that we have worked out yesterday, the responsibility for learning. All right. Now let's assume that D1 are the scores of the participants of the test during the first occasion. And let's assume that D2 is the same test that was answered by the same participants on a second occasion. And we want to determine test-retest reliability, making use of a correlation coefficient. All right, so you just have to click descriptives. Okay. And then enter D1 and D2. Put it on the next panel. Okay. The menu down is not shown. Okay, let me redo this one again. Okay, let me try here inside regression. Okay, so click regression, click correlation. Okay, then select the variables. So let's say D1, okay, and D2, D1 and D2 is your test, retest. D1 is the first occasion, D2 is the second occasion. And I enter the arrow down here, and then the two observations are dragged on the right side. Okay, so you can click here, Spearman, Pearson R, because Pearson R, okay, is the one that is appropriate to use. Okay, and then I place a check here to report whether it is significant or not. Okay, and if you want to see the scatter plot, okay, you can put a check here to view the scatter plot. Okay, if you click here going to the right, okay, it's my data is being run, all right? So you will see that the correlation, okay, is 0.43, and that correlation, okay, is significant, okay, at 0.001. So it means to say that the scores are consistent between D1 and D2, between the test and the retest occasion. Okay, and here is how, here is what the scatter plot looks like. Okay, so this is how this, this is how the scatter plot looks like. So this is how you get it, making use of JASP. Okay. Next, let's go back to our presentation. Okay, next. The next type of reliability would be the parallel forms. Can you see the slide again?
Yes po, Doctor.
All right. Okay, so parallel forms of reliability. In parallel forms of reliability, you have two versions of your test or your measure. Okay? The two versions of your measures exactly measure the same characteristics, the same variable, the same skill, the same competency. Okay? So whatever characteristic that you're measuring, they're measuring the same thing. However, the items are different. Example, if you want to assess, for example, addition skills, item 1 can be 1 plus 3. Now, in the next version, the first item can be 3 plus 1 or 2 plus 1. So it's very parallel. If item number 2 in the first version is 23 plus 4, item 2 in the next version can be 21 plus 5. So you see, you have 2 digits plus 1 digit. You also need to have the same form, the same format in the next form. So you have 2 versions, but these 2 versions are parallel or equivalent. They're measuring the same variable. They're measuring the same characteristics. Okay? So you have 2 versions of the test. Usually, these 2 versions are called as your forms. Okay? Example would be Form A and Form B, or Form 1, Form 2. It depends on what name that you have for these forms. What happens in parallel forms reliability is that you administer those 2 forms or those 2 versions of your measure to the same group of participants. Therefore, for each participant or for each examinee, you will have 2 sets of scores, one for the first form and one for the second form. What you now do with these 2 set of scores in order to say that your 2 forms are equivalent or parallel is to correlate again the scores. And you do the same thing in the same procedure like what we did in JASP. You need to arrive at a correlation coefficient, and the correlation coefficient needs to have a positive magnitude, and the correlation coefficient needs to be significant in order to say that the 2 versions or 2 forms of your test are parallel or equivalent. Okay. So that's parallel forms of reliability. Now take note that test-retest is temporal stability. We're testing the reliability across time. Parallel form can be an external form of validity because you have two different forms here that are equivalent. Okay. Next. Okay. The third one, you have a split half. In a split half, you have one test and you administer that one test to your participants. However, during your scoring, you separate the items into two halves. Example would be an odd and even split. Okay, what is an odd and even split? You can actually get the odd numbered items, okay, and separate it with the even numbered items, 2, 4, 6, 8, 10, and the odd 1, 3, 5, and then get the total score for the odd numbered items and get the total score for the even numbered items. So get 2 scores for each participant because you separated the test into 2. But again, take note that when you do a split half, okay, make sure that the contents of your items are all measuring the same characteristic. Let's say you have a 10 item test. Make sure that all of the 10 items would be the same. If the skill that you are measuring in math, for example, is determining whether the number is greater than or less than, make sure that items 1 to 10 are all about greater than and less than. Hindi pwede now 1 to 5, greater than and less than, and then suddenly 6 to 10 are problem solving. Because these are already different skills. Make sure that items 1 to 10 consistently are measuring the same characteristics. Okay. Now just take note. So what happens here is that after you get 2 scores for the 2 halves of the test, you correlate these 2 halves, and again, you get a correlation coefficient. And the magnitude should again be positive and better if the correlation coefficient value is significant. However, what you need to take note here is that you're correlating only half of the test. So there's a correction term for that one, and you use a Spearman-Brown coefficient to do the correction for that one. So you actually, in principle, double the correlation when you do a Spearman-Brown coefficient after you compute for the correlation coefficient. So split half only requires you to have one measure. That's why split half is a form of internal consistency. You're estimating reliability within the same measure. That's why it is a form of internal consistency. All right? We go now to the more accurate measure of internal consistency. Okay, so when you say internal consistency, it means that you're looking at whether the responses across the items in your measure or in your test are consistently answered by your participants. If you have a 5-item test, okay, you have to ensure that at least the participants are answering consistently in these 5 items. But again, our criteria, make sure that the content of your 5 items are the same. If items 1 to 5 should be able to measure greater than or less than of 2 numbers, make sure that all of these are about greater than and less than. Don't mix it with other skills. Okay? This is an assumption that you need to do in order to respond consistently, for the participants to respond consistently. If a participant are able to answer correctly item 1, it should be the same for 2, 3, 4, 5 as well. And we have accurate measures or estimates to determine internal consistency. The classical way, okay, is using your Kuder-Richardson. However, your Kuder-Richardson is only applicable for measures that are dichotomous, meaning to say you only have 2 options. It's either a right or wrong answer, a yes or no, or A and B only, the options. However, what if you have measures such as a Likert scale, where you have a 5-point scale from strongly agree to strongly disagree? So you cannot use the Kuder-Richardson anymore. That's why in 1978, Lee Cronbach derived the formula of the Kuder-Richardson into what we call as the Cronbach's alpha today. So the Cronbach's alpha is very versatile. You can actually estimate internal consistency, okay, of different measures ranging from rubrics, ranging from Likert scales, ranging from tests with right and wrong answers. So you can use Cronbach's alpha in any of these. However, okay, recently at the onset of the 21st century, there were now several criticisms about the use of Cronbach's alpha. Cronbach's alpha is said to be misused. Because Cronbach's alpha, we are assuming in Cronbach's alpha that when you get a value of 0.80 and above in your Cronbach's alpha, we arrive now at the interpretation that the items, that the responses to your items are internally consistent. However, okay, when you do a confirmatory factor analysis, you will notice that the standard error of estimates would greatly vary across your items, especially if you have a one latent variable and you will put the items under your one latent factor, and you will see that there are error estimates for every item that you have, and they greatly vary. If the standard errors vary for every item, explaining their contribution on the latent variable, then there's a problem with internal consistency now. However, your Cronbach's alpha will tell you, when you compute for your Cronbach's alpha, it will tell you that your items can be reliable. You can get a value of 0.80 and above as long as you have about 100 items or so. But when you estimate standard errors in a CFA, okay, the standard errors will not be the same across. Meaning to say, the variances explained of each of your items do not co-vary. But when you compute for Cronbach's alpha separately, you will get a high Cronbach's alpha, because Cronbach's alpha is sensitive to very large pool of items. And this is now your problem with the idea of reliability. If items are consistent, internally consistent, they need to co-vary even the kind of standard error estimates responded for each item. And this is now your problem with Cronbach's alpha. Okay? However, Cronbach's alpha is mostly used because most of the available softwares that you use to estimate Cronbach's alpha is available. So they derive an alternative to Cronbach's alpha, which we call as your coefficient omega. So you have alpha and the omega. So take note that the Cronbach's alpha is useful when you have measures that are unidimensional. Take note, the one that I illustrated a while ago. If you have items 1 to 5, make sure that all of your items 1 to 5 are about greater than or less than. However, Cronbach's alpha will be deemed useful that if you put these 5 items under one latent variable, and you put these 5 items and load it in a CFA as one latent variable, you need to see covariation among your standard error of estimates across these 5 items. If you are not able to attain similarity in your standard error of estimates in a one-factor CFA model, then you violate the assumption of using a Cronbach's alpha. Okay? Therefore, in the estimation of a coefficient omega, this particular weakness is resolved because the computation takes into account the covariances of the standard errors of your items under a unidimensional measure. Or like what we have talked about yesterday, if you load those 5 items of greater than and less than items under a one-factor model, it automatically accounts for in the computation covariances of those 5 items, covariances of the standard error of estimates. When we have attained covariances of the estimates of your unidimensional measure, then we attain what we call a tau equivalence. Now, in such cases, the Cronbach's alpha can also be useful especially when the items are unidimensional and there is no correlation errors. When you say there is no correlation error, you get a very, very low standard error of estimate for your Cronbach's alpha for each of the item. And the average loading should be above 0.7. So if you do EFA, okay, the first extraction in your eigenvalue, when you get the average of the factor loadings, the average should be above 0.7. And it's impossible to attain that one. Third condition, okay? If you get the differences between your individual factor loadings, you should not get any difference of below 0.2, or else, meaning to say you have a large covariance. So if each of the item has a zero specificity, or each uniqueness is solely from the measurement errors, then you can do Cronbach's alpha now. However, given these conditions, it's difficult to attain all of these conditions. Therefore, if we are not able to attain these conditions, then it is inappropriate to make use of the Cronbach's alpha. That's why your alternative is the coefficient omega. Okay? Yes, so this is the arguments found by Rykov and Mercules. And then Markov and Mercules was able to look at differences in the estimation of the Cronbach's alpha and the Cronbach's omega in their publication. Okay, so they made use of the following tests. Okay, they used the spatial, verbal, speed, memory, and mathematics test. And they estimated the internal consistencies of these 5 tests, making use of both Cronbach's alpha and Cronbach's omega. And they estimated Cronbach's alpha and Cronbach's omega making use of a confidence interval, and they reported the root mean square error approximation of the confidence intervals of both for Cronbach's alpha and Cronbach's omega. You will notice that the estimation of error, which is root mean square error approximation, is larger for the Cronbach's omega, meaning to say Cronbach's omega is more sensitive in detecting the error as compared to estimation of your Cronbach's alpha. Therefore, it's more accurate to make use of your Cronbach's omega. Okay? Now, let me demonstrate how to obtain Cronbach's omega making use of JASP. Okay, I'll just cross out here. Now take note that, let's work out on my 10 items on deportment. So D1, D2, D3 to D10 on my screen are deportment. By the way, can you see my JASP screen?
Yes po, Doctor.
Okay, can you give me 1 minute for a restroom break for a while? Just take a look at what's shown on the screen for a while. Okay, we're back. So let me demonstrate how you compute for Cronbach's alpha and Cronbach's omega making use of JASP. So again, plug in your data, open your data inside JASP, and then you will see here on top reliability. Click the reliability, okay? Click classical single test reliability. Okay, and then in this particular case, we'll compute for the Cronbach's alpha and Cronbach's omega of the deportment items, which is 10 items. So I select D1 until D10. Now, why will I not include the learning process and the motivation subscales? Take note, Cronbach's alpha and Cronbach's omega works under the assumption that our items are unidimensional. They're measuring a single construct. Therefore, you don't have to combine the items for the other factors, or else you violate the assumption of unidimensionality. Okay, so put it in. After you put it in, you scroll. Oh, by the way, let me put it back. I want to show you how to check below. It's not coming out. You should be able to see below. Okay, let me, it's not coming down. Okay, let me put this back. I wanted to show you below, but my screen couldn't go down because you can check actually both Cronbach's alpha and Cronbach's omega below. But my screen is not permitting me. Let me work it out. Ayun. Okay, so here, you click on single test reliability. Okay, you see McDonald's W here. You put a check on McDonald's W. If you also want to estimate Cronbach's alpha, you can put a check on Cronbach's alpha. If you are estimating for unidimensionality, you can use Guttman scales here. The Guttman scales here are also provided. However, it will take us a longer story. You see here a greater lower bound. Greater lower bound reliability can be used if your items belongs to more than one factor. However, I need another session to explain the greatest lower bound reliability. Let's just stick for a while on omega, the alpha and the omega. So you put a check on both alpha and omega. Okay, go back to your data. Enter now your D1 to D10. Put it on the other side, and it's now estimating, JASP is now estimating your alpha and your omega. It's just taking long because I have more than 2,000 observations. Okay, here it goes. So you will now see here on the screen that the point estimate, your estimate for your Cronbach's omega is 0.832, and your Cronbach's alpha is 0.831. Okay, so you will see here the confidence intervals. You have 0.817 to 0.845. And for your Cronbach's alpha, your confidence level is 0.819 to 0.841. If you get the difference of 0.845 and 0.17, the difference here is about, okay, let me just compute 0.845 minus 0.817. So you get a difference of about 0.028. And for your Cronbach's alpha, you have 0.841 minus 0.819. Let me, 0.841 minus 0.819. So you get a difference of 0.22. You will notice that confidence levels for Cronbach's omega provides you a larger confidence limit, meaning to say, okay, it gives you a more accurate estimate of internal consistency. Okay, so you can later on do and copy this one, and then you can paste it later on in your report, making use of your Microsoft Word. Okay, we go back now to our PowerPoint presentation. Okay, and yeah, we go to the next form of reliability, which is your Interrater reliability. So in Interrater reliability, this is usually applicable if you are assessing performances. Okay, performance-based tasks like singing, dancing, you have a beauty contest, so where you have a rating scale or a rubric to assess the performance. And usually this is applicable if you have 2 or more judges. Okay, So the judges will make use of the same rating scale or rubric to assess more than 2 observations. And what we are after in Interrater reliability is the consistency of the judges' rating. Okay, and the consistency of the rating can be estimated making use of an estimate called as the Kendall-Stowe coefficient of concordance. So if your Kendall-Stowe has a positive magnitude and is significant, even if the Kendall-Stowe value is small, then you can say that there is consistency across your ratings or from your judges. Okay, so let's do our next exercise now. So we'll continue on. So I'll be presenting to you a particular case, and then you tell me what kind of reliability. Let's review. The first reliability you have, okay, let's call our participants. Let me stop sharing for a while. Okay, Janelle May. Janelle May. Janelle May. Janelle is missing. Janelle. Janelle May. Okay. Marge Mabansag.
Yes, sir.
Okay, let's review. So what are the different forms of reliability? The first one is
Test-retest,
test-retest.
parallel forms,
Parallel forms.
um, internal consistency,
Split
or
half.
split half, split half,
Coefficient.
and coefficient alpha,
And coefficient. The alpha and the
omega,
omega. And internal
internal interrater,
interrater reliability. All right, again, Marge, in order.
test-retest, parallel forms, and
Split half.
split half, coefficient alpha and omega, and interrater reliability.
All right. Okay, let's work this out with you now. Let me share my screen again. Okay, you see my screen now, Marge?
Yes.
Okay, so Marge, look at the first one. Mr. Perez administered an inventory to his students to determine their study habits. Each item is answered using a 5-point scale, always, often, sometimes, rarely, never. He wanted to determine if the responses for each items are consistent. What reliability technique is recommended? Go ahead, Marge.
Cronbach alpha.
Okay, why Cronbach's alpha?
Because the point scale is Likert scale, and then the response is not dichotomous.
What is Mr. Perez after here? What is he after?
The study habits.
What does he want to do with the study habits?
He wants to measure the internal consistency.
Yes, he wants to determine if the items are internally consistent. So he can use the Cronbach's alpha.
Yeah.
Now, let's say you have 4 factors of study habits. How many Cronbach's alpha do you need to compute for, Marge?
4.
Yes, you also need to have 1 Cronbach's alpha for each factor. Why not 1 Cronbach's alpha for all scales?
Because Cronbach alpha is a unidimensional.
Is used for measures
of unidimensional data.
Okay, now, let's say that I did CFA for the first factor of study habits. Let's say reviewing and reading is my first study habit factor. And let's say I did CFA and I placed that under 1 latent factor and I estimated standard errors. And my standard errors are very discrepant. Is it appropriate to use Cronbach's alpha?
No, sir, because Cronbach alpha is very sensitive. I mean, very lenient in terms of the errors.
Cronbach's alpha does not consider the estimation of covariances among standard errors of the items. Okay, so what is now my alternative to determining internal consistency?
Coefficient omega.
Okay, so I now use coefficient omega. All right, thank you, Marge. Okay, next, Jennifer. Jennifer Mangali.
Yes, sir.
Jennifer.
Good morning.
All right, good morning, Jennifer. So number 2, a teacher administered a spelling test for her students. After a day, another set of spelling tests was given with the same length and stress of the words. What reliability can be used for the 2 spelling tests?
I think, sir, test-retest.
How many tests were given here?
One only spelling test.
Read the second sentence. Jennifer, read the second sentence.
2 sets, sir.
There are 2 sets. What are the 2 sets measuring?
Sir, parallel form, sir.
Yes. Okay. Number 2 would be parallel forms of reliability. Why?
Yes, because you are given 2 tests which determine the same in form, but they are given at different time.
Okay. How many scores will I get for each examining?
2 sets of scores, sir.
2 sets of scores. What do I need to do with these 2 sets of scores to determine if my 2 tests are equivalent?
You have to make a correlation of the 2 test scores.
Okay, and what should be the magnitude of my correlation coefficient?
Should be positive, sir.
All right, very good. Marge, you're able to answer accurately. Jennifer.
Thank you,
Okay,
sir.
thank you, Jennifer. Next, Sherwin. Sherwin.
Hello, sir.
Hello. So we'll have another round again, ha? We'll go back to Marge again after. Okay, so Sherwin, this one number 3 is for you. A PE teacher requested 2 judges to rate the dance performance of her students in physical education. What reliability can be used to determine the reliability of the judgments?
Interrater po, sir.
Why Interrater?
Because Interrater reliability is applicable only for assessing performance assessment.
Okay, so yeah, 2 because, and how many judges do you have?
2.
Yes, in this particular case, you have 2 judges. All right, very good, Sherwin. Next, we'll go back again to Marge. Marge?
Yes, sir.
Okay, number 4, Marge, for you. An English teacher administered a test to determine students' use of verb given a subject with 20 items. The scores were divided into items 1 to 10 and another for items 11 to 20. The teachers correlated the 2 sets of scores that form the same test. What reliability is this?
Parallel forms.
Parallel forms. Why parallel forms again?
Because you have 2 sets or 2 forms that you need to correlate with.
Yes. Okay, and what are we after here? Parallel forms ba ito? How many tests do you have here? How many tests do you have here, Marge?
2.
Oh,
wait.
Read the first sentence.
Split. I think it's split half.
Why split half?
Because it is the same test.
You only have 1 test.
Yes.
Then what did you do with that 1 test?
Divided into 2.
Yes. How did we divide the test into 2?
1 to 10 and then 11 to 20.
So how many scores will you obtain for each student?
20.
20 scores?
Oh no, 2 sets of scores.
2 sets of scores. The score for 1 to 10 and another score for 11 to 20, right?
Yes.
And that's what you correlate. So again, what do we use here, Marge?
Split half reliability.
Split half. Yes, split half. Okay. The next one would be Jennifer again for number 5, but I'd like to see the answer of the audience. Okay. for number 5. Okay, I want you to type your answer for number 5, everybody, in the chat box. Okay, I will read first. A computer teacher gave a set of typing tests by Wednesday and gave the same set of the typing test for the following week. The teacher wanted to know if the students' typing skills are consistent. What reliability? Okay, everybody, type your answer. Send. Send, everybody. Okay, I can see your answers. All right. All right. Yes, Jennifer, what is the answer for number 5?
Test-retest, sir.
Yes, this is test-retest. So majority of your answers in the chat box are correct. All right, so that's the end of our presentation. And let's take a look at the questions, okay, in the chat box. Okay, the first one from Jerwin. Is it possible for the respondents to get high mean scores during the 2 administered tests yet result to low reliability? Yes, you can get very high mean scores, but then the tests will not be consistent because your estimation of means is not the same as estimations of correlation coefficients or linearity. Okay, again from Jerwin. If the latent variable doesn't pass the reliability test, let's say convex alpha is very low, can we use this variable in stat mod? You have to explain, Jerwin, I don't understand quite well your question here. If the latent variable doesn't pass the, meaning to say, let's say you got low Cronbach's alpha, can you still use, what do you mean stat models? Can you proceed with CFA? Is that what you mean? Let's say you got low reliability, but can you still proceed with the CFA? Is this what you mean, Jerwin? Jerwin, can you speak because I couldn't scroll down? I might lose the other questions that follows. Jerwin? Okay, anyway, I think what Jerwin means here is that, let's say, initially you computed for convex alpha, and let's say you got 0.3 and it's low. And then you wanted to do further analysis like your CFA. Can you proceed with your CFA? Well, yes. Here's what you can do. In your CFA, okay, assess the fit of the model. Look at the parameter estimates. If your model is not fitting, make some modifications in your model. Take out those items with low parameter estimates. Then you're left with a reduced number of items. After you reduce the number of items, try to compute again for your Cronbach's alpha and Cronbach's omega. Try to see if it improves. These are iterative process that you can actually do. Okay, Jenny Lynn, are JASP and statistical alternatives to SPSS? Okay, there's no such thing as alternatives, but there are many softwares and applications that you can use out there to help you compute for your statistics. These are not alternatives. No, they will sue you if you say that these are alternatives. All of them are available softwares for you to use, and they are not alternatives. Jenny Lynn. Okay. Jerwin again. Can we establish reliability of a questionnaire or do Cronbach's alpha after collecting data from a whole sample without conducting pilot study? The answer is yes. Yeah, sometimes, for example, you wanted to do an experiment and your experiment doesn't allow you anymore to do pilot testing before the conduct of experiment because of limited funding, etc., etc. You can actually make use of your actual data in your study and use that to estimate your internal consistency. I just noticed that this is becoming a practice among people I know while completing the bachelor's. Yes, because it's allowed to do that, especially if you're not really after the validity and reliability of your questionnaire. You're just after really on proof that the measures or the instruments that you're using are reliable. You can make use of the same data that you are using for your actual study. Is the reliability test with Cronbach's alpha sensitive to sample size? Yes. Okay. They are sensitive to sample size, especially for the Cronbach's alpha. If you have a very, very large sample, tendency is that you get very high Cronbach's alpha. Cronbach's coefficient omega requires you to have a large sample size as well. Okay. On Interrater reliability, what if 3 judges are tasked to rate 5 contestants? Stage present, you have a percent. Here are the fictitious scores. Okay, can we say that there is reliability? Okay, in order to say, Jervin, if you have these scores, you need to compute for the Kendall's Tau. You have to input 84, 90, 80, 95 for Judge 1, then for Judge 2, for Judge 3. Okay, and then you have to do the computation. And the Kendall's Tau needs to be significant. Even if you see some deviations here, you can't really judge through just looking at the scores whether it's discrepant or not. It's really the coefficient of concordance that will give you the internal consistency, the interrater consistency. Okay, let me show you how it will look like when you plot it, Jerwin. Let me just open my slide. Okay, for a while. I'm checking my slide where I can actually pull this out because I took out those tables showing the formulas because okay, here is how it will look like when you plot it and compute for Kendall's Tau. So everybody, you can see my screen now with the table.
Doctor.
All right. So Jerwin, this is how you plot it. So let's say you have 5 candidates, A, B, C, D, and E, and you have 3 raters, rater 1, 2, 3. What you put here inside, the intersections are the percent that you have obtained. Then, Jerwin, you compute, you get the sum of all of the, you get the sum of the ratings, and then you get the mean of the ratings, in this case, it's 8.4. Then what you need to do is to subtract each of the sum of the ratings with your mean, so you get the D. And then you square each of the D to eliminate the negative sign. So, and then summate that, you get a summation of D squared. And then, Jerwin, use this formula, just plug in the values in this formula, and you will get an estimate of the Kendall's Tau coefficient. And this is the one that will tell you whether you get interrater reliability or not simply looking at the actual scores. Okay, let's go back to the questions. Parallel, split half. Okay, another. How many respondents are required for pilot testing for a test construction? Okay, recommendation, at least 100. Okay, sorry sir, dami tanong. Maraming salamat at pag-address ng tanong. All right. But Jerwin, I would most appreciate if you could explain and turn on your microphone for some of your questions. Okay. Alfie Badilla, good day po. How do we know if the data is manipulated and not really the result of the survey of the actual test? Yeah, there are estimations for that. Alfie, usually there is a technique called item response theory. In an item response theory, you can actually estimate the guessing parameter for each item. Okay? Yes, you can actually do that one. Also, Alfie, what they did, I have a friend who is a psychometrician from the college board. Okay, and this is what they did. They compute the time spent in an online test because now it's the pandemic, so most of their tests are administered online in the college board, the CBBE, CBBC in the United States. So what they do is that they estimate the time spent in answering each of the item. And then they look at the, aside from consistency of answers, they look at the consistency of time spent in answering each of the item. And they compare that, how many are getting correct versus incorrect. There should be a good match between getting a correct response and the time spent consistently across. They use a multi-level modeling to estimate that one, to determine which particular item resulted in accuracy rather than on guessing. Example, if items 1 to 5 are answered all correct, Correct for item 1, correct for item 2, correct for item 3, correct for item 4, correct for item 5. The time spent should also be the same. And they have estimation for that in the College Board. Now, and then they graph it. Let's say, for example, towards the middle of the tests, okay, all of them are getting correct answers, and there's a slowdown. But then suddenly, towards the end of the test, they're speeding up, and all of them are getting the correct answer. So they're meaning to say that the first few items, someone is coaching them. Okay, so that's how they actually have determined. Will we be able to get have a copy of the presentation? Yes, I've already sent it to the organizers, including handouts and reading materials that you can read on validity, reliability, and EFA, including the journals that I use for in the presentation, the actual journals. Jerwin, in test, retest, and parallel forms, are we actually validating the scores and not the questionnaire? I just thought that the students answering aptitude tests have a tendency to change answers over time. Okay, this is a good point, Jerwin. Reliability is more of a characteristic of the responses rather than the characteristic of a test. Okay? Yes. That's why reliability is more in reference to the responses rather than the tests. Because concern about the content of the test will be more for validity rather than reliability. Okay, next. Abel, you are watching TV. I can hear your sound. Okay, and then I just thought that the students answering aptitude have the tendency to change over time, though the questionnaire itself remains the same or equivalent. When I decide how long is the interval between tests, yes, you can actually decide, but for aptitude tests, which are more stable, you can make the interval a little bit closer or a little bit farther pala, because it's more stable. But for some tests that are a bit unstable, make sure that the gap is close or small or that. If the scores are ordinal in nature, will the Kendall's tau be still okay to compute? Yes, even if the scores are ordinal, you can still compute, but you can make use of the Spearman raw. However, if you have 3 judges, you'll have about 3 Spearman raw. Correlation between judge 1 and 2, correlation between judge 2 and 3, and correlation between judge 1 and 3. 3 Spearman raw, if it's ordinal. From Jennifer, thank you, Dr. Magna. We appreciate this time for you. Thank you for your effort and dedication. All right. Are there any other questions? No more? Okay, that's it.
For questions na po. Marami pong salamat, Dr. Magno. Thank you so much po. May we request for a picture taking po, everyone? Mabilis lang po. Okay po, ready, frame 1. Ready, 1, 2, 3. Next, frame 2. 1, 2, 3. Frame 3. Frame 4. Frame 5. And last frame. Okay po. Dr. Magno, maraming salamat po for gracing our 15-day capacity development program on data analysis. We have really learned a lot from you, Doctor. Maraming salamat po. Sa uulitin po. Thank you po. Thank you, Doc. Our dear participants, your certificates will be available tomorrow po. We will upload it sa Google Drive po natin. So please check from time to time. Please give us time lang po to encode your name sa mga certificates po. Okay po? We will be uploading them tomorrow until 5 p.m. po. So pa-check na lang po. Maraming salamat po. We'll see you again to our next training. Maraming salamat. Have a good lunch. Thank you po. Thank you. Sobrang thank you po.